Hello there, ladies and gentlemen, and welcome to today's little nice video. So we're not only talking about those kitchen cabinets that I want to show you how we can make them today, but also in general like about the philosophy of Grasshopper and how it actually helps you with your design. So if you want to see why a design with Grasshopper makes more sense with designing your projects than when you would do it manually in Rhino, you should watch this video and learn of how to use it, or at least try to. It's just all learning process, you know? Okay, so let's get into it. Anyhow, so imagine the following, okay? You have a kitchen cabinet like this one, and we want to create them in the Grasshopper in the Rhino environment. So if we just take a look at like normal kitchens and like those ones, and we have different ideas of how we want to lay out their kitchen, and you always have this bottom part where you can put drawers in and put stuff in, and you want to have a general feel of or layout feel where you put this. Problem is, there's always different angles here, as you see. Sometimes they're rectangular, sometimes they're just straight on like this, sometimes they have like a weird angle, whatever. So if you would just forget about the Grasshopper environment, if we would go to Rhino, it would basically mean, okay, we make a rectangle, then we make something like this, then we're gonna extrude it, extrude the curve like that, and then we would go to the correct thing like this, and then we use another one, and we're gonna copy it from here to there and from here to there, and now we want to use another one here, and I'm just gonna copy this one in here, and then we're gonna rotate it, I'm gonna move it up here, and so on. And then we can also like define our little like rectangular boxes there at the front, like that, like this. We're gonna move it here, and then we're gonna move another one here and here, and then we have to also copy them around like that. This one goes here, and so on. Problem is, when now someone says, okay, this is all fine and good, but now I want to have it like on a shape like this. So that means, okay, then I need to just like take this and move it here, and then we have to rotate it to a certain angle, and then suddenly this is kind of weird. We need to like rotate it again like that, like let's see, like this or something, and we move it, and then it doesn't really fit anymore. It goes into all kinds of problems, and then suddenly you want to say, okay, but I want to have this like ground line somewhat different again. Then you need to change everything by hand again. That's absolutely outrageously unuseful if you are designing on some things that need to be like have a certain consistency over like longer amount of time. So that's why Grasshopper in those cases is like really useful, because right now when I want to decide, okay, I want to just change those things around and change them a little bit, and then in the end I would just say, okay, I'm happy with the result, and I can just bake it, and then it's basically all the way of how I want it to be, and I can use it for other purposes again. You see, it's like it works, and I don't have to like change it around. So we're going to create this cabinet, and I just show you how we can define those things or translate those things from the Rhino environment into the Grasshopper environment. Anyhow, let's start with a new file. So we're gonna delete this, and we're just gonna start with a very like simple polyline, okay? Like one that goes like this, like something like that. And maybe, so this will be like our baseline for our kitchen cabinet, So just gonna put this here. So what we're basically going to do, I'm just gonna sketch this out for you real quick so you can understand it without any problems. So we're going to create this line that's already created. Then this line has to gets like a second line, like an offset of this line. Yes, and then we're going to extrude them upwards and basically have a line around here like that. And then furthermore, once we have this line defined, we want to create certain like cutouts at certain parts, and those cutouts then will be places where I put other kitchen cabinets in there, like that, you know. And then once those cutouts are made, we are putting like the drawers in here, like that. Yeah, very simple, like this. Just continue it like that. So that's all we want to basically do. And normally if you would do it in the Rhino environment, you would make the portal line, then make another line up here, extrude it upwards, just how I showed you, and then make each individual place pop out a little bit, and so on and so on. And we were going to do this a little bit more, let's say, computational. So first of all, we're going to take the geometry here and we're gonna put it into the Rhino environment. So this is now in the Grasshopper environment. I mean, now this will be displayed like this here, and we're going to make an offset. So we just double click the canvas, then do offsets, and then we offset this curve like this. And here you see it's gonna go into this one direction. However, we want to also create a slider, so we just double click, do -1, and then less than, or higher, taller than, less than, whatever, and do one till this one, and then we can create a number that goes from this side to the other side. This would be like the offset that we created here. We're actually gonna, I'm just gonna scale this down a little bit, so we have like more, if you're talking right now in meters, it should be in meters, then I need to just change this quickly. It doesn't really matter in which unit you draw, but it is a good measure to know which size you want to use. So this will be now in meters. Then we're going to create a division in between those cabinets. We're just going to divide this curve here, divide this curve here, and those will be our points where we want to divide them. And then we also want to use the evaluate curve parameter and create a gene pool that creates parameters between 0 and 1. So we can right click edit and then do the maximum of 1. And this will be our gene pool for the parameters on the curve. So we're going to use this curve here. However, now you see it will be just parameters here directly in the beginning. If I change this one, you see it changes around here. But we need to reparameterize the curve in order for it to be between 0 and 1. I will do the same here, up here as well. I guess we can just do it materially, but yeah, it might be important to do it later like that. And we're also gonna edit the gene pool in order for it to be like a few like less custom drawers that we want to place in here as well. So great. Now that we have that, we want to basically create a line like this one, you know, like that goes perpendicular to it. And that's very easy to do because we're gonna, for example, if we're at the division curve, we're gonna use a STL, line STL, so it will be like the start point, tangent, and length of the line. And we're gonna use the starting points of here, and it goes in the direction 0, 0, 1, but we want to go it into this direction here. For that we can use the tangents. However, it will go directly on the direction of the curve. So we want to basically rotate this vector. So we're gonna rotate it by the 90 degrees, and we're gonna do this by rotate vector. And the vector will be the tangent, and the axis will be a vertical one. So we're going to use the same start point, and then like this one here, and we're going to use this as the axis, and we want to create the 90-degree angle for that as well here. So we're just gonna create this one here, right click on it, make degrees, just make sure, because we don't want to use radians in this case. This then will be the vector that we're gonna use into the STL, like into the direction of our cutting curve, like that. And you see this looks already pretty good. However, if we would change this around, you see it doesn't really fit to that, so we need to make sure that this also equals with the offset of the curve of the kitchen width. Just trying to rename this quickly, like here, and I'm gonna put this into the length of it. And as you see, it goes into the wrong direction, so we're just gonna right click it, go in expression, and then do -x. It will make it negative, and you see now it will go into the other direction. Great. We're gonna hide this with Control Q or right click and hide preview. And however, now that we have that, we also want to have those custom points that we have here. Now we can import them by, for example, doing a merge, and then we're just gonna merge the points from here and there together. And you see it will give us two different like list formats. So one is branch formats, like one is 0 and the other one is 0, 0. And we want to basically merge them together. This can be done by simply flattening them, and then you would have them just in one branch like total. And we're gonna just Control Shift and click them over and put this on here. And we also want to do the same thing with the tangents as well. Tangents, whatever. Words are sometimes not usable if you're trying to concentrate and record a video at the same time. And we're gonna flatten those here as well. Now that we have those, we want to use them as the direction as far as I know. Now we have the vectors here, and I used the wrong one, so I just used the parameters. So great, now we have our points defined here as well, and if we see and we move them around, we should see a yeah, you see there will be a point and it flips over just of how we wanted it to flip over. Great, cool. Now that we have that, we are going to hide those things now, and we want to create also basically have now the basic shape defined like this, and we also want to well, first of all, we're just gonna do a simple extrusion. So we're gonna extrude those things first upwards, so we can just use either that one, or we can actually use a ruled surface between this first one and the second one, like that. And this kind of throws us some wrong results. That might be because, not because it's flattened correctly, but I think we might need to loft it together. Yeah, this looks better, yeah. We have the lofted surface, and this lofted surface then will need to be cut with surface trim, and this is under intersection, and then physical, and then surface splits, and this will be our lines, and this will be our surface that will need to be splitted. And this now gives us several different fragments of our curve here, so that's pretty good. And we're gonna just simply extrude this upwards then as well. So we're gonna use this one as the base. We can use the surface as the we don't need to have lines, but it needs to be something at least. And we're gonna also need to use a factor of, so this would be the kitchen height. Great, good. Now that we have that defined, we might still, yeah, exactly. What's still missing are those like little drawers that we want to define here in the beginning. So we basically need to, if I just go back to our drawing here, we basically need to take this part here and make like a small rectangle here, and then just duplicate it upwards here. So we can do that because we already have our points defined where we are going to need to put those things here in. So those are the parameters of the curve, and we either have them here and there. So we're just gonna use the shatter command, take the curve that we have here in the beginning, reparameterize them, and then do a merge again from the parameters that we have here and the parameters that we defined ourselves. And then we're gonna put those two together And we're gonna flatten the parameters in this case. Again, just draft them, flatten them, right click on it, and then you can do it like this. Perfect. Now we have our like 14 different curves, and we also have over here 14 different B-reps. And we want to make them a little bit smaller, because right now the curves are basically like, if I just right click and pick them, you see one curve is here and then the next one starts over there. But I want it so that those curves are a little bit smaller. So I'm just going to use the extend curve command, put this one in here, and then actually do a minus, so I just like a little bit smaller, and I put it into the start and the end points of that. And we have to reduce this amount as well. And this, as you see, it makes the curve a little bit smaller here in this case. And now that we have that, we also want to pop them, make them pop out a little bit. So we're just gonna use this by gonna do a simple offset curve. Gonna offset this by a certain amount, maybe make it not 1 meter, but a little bit smaller, obviously. And then we need to connect the endpoints together. So we're just gonna use the endpoints here and the endpoints there. And now you have to be careful, because if you not connect them with the line command together, like the endpoints here and the endpoints there, it will gonna look like this. And this is because when you're using the offset curve command, they're actually creating separate branches for each curve that has been offsetted, and we want this to be like one thing. So we can just use the trim, either create flatten that. However, might go into complications, so we're just gonna trim the tree a little bit down. So we're just gonna use the trim tree, and it trims the amount of branches like a little bit smaller, like so it takes the end away. And we're gonna put this into the curves that we are going to look at the endpoints, like where we are looking for the endpoints. And now we have those very nice lines in between those curves, and we're gonna use this for the starting points as well. Just gonna copy this one over here. And what further need to do, just we're gonna use the merge command again, a lot of merging today, and put the initial curve in there, the trimmed tree, and then the 2 lines that we defined here. And now we have like very nice lists of those, and we can just use join curve commands, which would give us our little like cabinet drawers here, which are pretty neat. And I just make them a little bit smaller like that. I'm gonna rename this cabinet drawers. A very interesting word. Anyhow, now that's defined. We're just gonna hide those things. We have the end result. And this one, I want to know move upwards first of all, and second of all, I want to give them a thickness as well. So we're gonna use the extrude command, and we're gonna extrude those curves upwards to the z direction, and by a certain amount. And yeah, that might be like a bit like that. I think that's pretty good. And we also need to copy them upwards as well. And right now we have a certain limitations of the height. So the kitchen height at the moment is 2 meters, and we don't want it to go even further than that. So we're gonna use the range command, which basically takes the kitchen, like the range from 0 to 2 meters 243, and then the amount of steps in between. This gives us, if we go to the panel option, it will give us a different amount of heights for each of those panels. And we're gonna use this as the factor in the Z location, and as for now you see it will just make something like this. And actually we don't want to do that at all, but we will actually want to move those extruded points upwards in the Z direction again as well, by the range of that. But then we need to actually graph the geometry of that so they're all moved up equally. So that looks already quite better like that. And we also need to always adapt them in a way as well. However, we can actually circumvent this, and we actually can make a division of the total height divided by the drawer amount that we have to define here at the steps. And this will give us then a height of like 1 piece. And as you see, they're overlapping like perfectly right now. Yes, they should. Yeah, they do. And we might want to make them a little bit smaller as well. So we're going to do a subtraction as well by a certain amount. So like that. And as you see, there's one like just being in the air over there, and we're just gonna remove in the move to the Z direction. We're just gonna cool index, and then we're gonna cool the last one with -1 of that list, and then now it's gonna be removed as well from that. So, and that's basically how we were creating those things. So just gonna let's rename drawer height and the drawer amount, and then we have all the cabinets, and then drawer with subtraction, and that's basically all the parameters that we need in here. So I think that's already it. So great. And now we can just, now the good thing is, again, obviously, because all parametric and stuff, we can change it around as we want to. What time is if I go to the, it even goes into the Z direction, even though there's some bugginess going on there. But as you see, we can move those things around and change them as we please. And the great thing about that is it still keeps all our parameters. And that's pretty great. And if I say, okay, I want to have a drawer exactly here at this place, I can always move one directly here with the gene pool and just move it around and make it as I see fit. And again, if I say, okay, the amount of cabinets, they have to be a bit small like that. Then I want to have less drawers like this. I just move them around as I want the whole time. And when I'm happy with the result, obviously we're just gonna bake everything. We're just actually gonna merge those two here. And like that. Gonna hide those. And when I'm baking it like this, just gonna group like this. They're very nicely grouped, and so there has one example like that. And when I say, okay, you know what, I want to have a different layout that goes like this, very weird kitchen layout, but okay. And I want to change around the parameters a little bit so they are in my weird dimension of human that are here. Then I can always adapt them as well, and then when I'm happy with them, it's gonna bake them again, group them, and I know I have another example. And that's how quickly it can go. Okay, there's a little buggy in here in the end, but I guess that's fine. So yeah, thank you very much for watching. I hope this helped you out. It's just a basic idea of how you can use and create Grasshopper, because the problem would be if I would need to make one, then Rhino would be faster, and that makes total sense. If I would make 2, Rhino would still be faster. If I need to make 10, then it might make sense to actually change those around and make a script for it. And if I need to make 100 or 1,000 or more, well, then it makes sense to learn Grasshopper from scratch without knowing anything about it. So yeah, if you have any questions, any things you want to know, let me know, and yeah, maybe I can make a tutorial about that as well. So have a great day, and see you in the next one.